Hello students, how are you? Hope all of you are doing well. I am Dr Smrutirekha and I welcome you all to Etuson. Etuson, education for better tomorrow. It's a digital learning platform for Odia and English medium students developed in Odisha. With us, you can get quality education which will help you to build your career. So, what are you waiting for? Please download the app and enroll yourself. So, without wasting much time, let us start today's class. Are you all ready for that? Yes. So, we can start our today's class. Okay, before starting the class, have you watched the previous videos which I have uploaded? If you have not done, please watch the previous videos because in my previous videos I have discussed about the concept of real number, Euclid's division lemma and Euclid's division algorithm. Okay, also I have solved the problem from exercise 1.1 of your NCERT book. So you can get the solution in the link which is provided in this slide. Now, are you curious to know what we are going to study in today's class? Okay, so let us start. So, what is there for you today? So, it is the fundamental theorem of arithmetic. Are you getting nervous by seeing the name of the theorem? The fundamental theorem of arithmetic. Is it complicated? Don't think so. It is very simple and at the end of the today's class you will be understanding that अरे ये तो बच्चों का खेल है जो हमने already fifth standard में किया हुआ है. So let us understand the fundamental theorem of arithmetic. Okay children. So uh, if you remember in your earlier classes, you know that all the natural numbers can be expressed in terms of the product of the prime numbers. So, like for examples, I hope you know what is prime number. So, prime numbers are the numbers which doesn't have any factor other than 1 and the number itself. Like for example, 2. So, suppose 2, if you want to write down the product of prime number, it is 2 only. Now you consider 6. 6 is equal to 2 into 3. Now you consider another example. Suppose you will take one two-digit number. So I will write suppose 15. So 15 is equal to 3 into 5. Let us take one three-digit number. So suppose I will take another number, that is 253. So 253 is equal to 11 into 23. So both 11 and 23 are prime numbers. So in this manner we can find out that all the numbers, all the natural numbers can be expressed in terms of product of prime numbers. Now let us go in the reverse direction, in which we will try to find out the number when prime numbers are getting multiplied with each other. For example, suppose I will take the prime number as 2 into 3. So 2 into 3 is 6. Now I will take up another prime number to it. So and multiply. So 2 into 3 is 6. 6 into 5 is equal to 30. So let us take another example. Suppose you have 7 into 11 into 23. So that is equal to how much? That is 1771. Okay, so now I will add another prime number to it. So 3 into 7 into 11 into 23, that is 5, 3, 1, 3. Okay, so again suppose I will multiply 2 to it. So what will be the number? So by doing all these things, so the number you will get is 10,006. So likewise, what I am trying to tell you that if you keep on multiplying the prime numbers, the numbers become more and more and greater and greater and greater. So is there any limit to it? Definitely not. So you will reach to one conjecture where you can say that if you tell the product of you will take the product of prime numbers, so you will be getting indefinite number uh, by multiplying the prime numbers. Okay, so this is In this way you can get, so there is no limit to it. So we can tell that all the numbers can be expressed in the product of your prime factors. This is nothing but your fundamental theorem of arithmetic. अभी ये सब पढ़ा हुआ है ना पहले से, correct or not? Okay, so now I will refresh your knowledge which you have studied by finding out the prime factorization of a bigger number. So, while doing the prime factorization, usually we adopt two methods. One is prime factorization method and another one is factorization tree. So, let us take one example of a bigger number. So, the bigger number is 32,760. Now this we will find out the factor of this number by using your prime factorization method. प्राइम फैक्टराइजेशन मेथड, ठीक है ना, प्राइम फैक्टराइजेशन मेथड और एक क्या होता है ना, फैक्टराइजेशन ट्री, फैक्टराइजेशन ट्री. So these two method we will adapt and we will find out the factor of 32,760. So how do you do for prime factorization? So basically we will try with the lowest prime number which is 2. So I will divide by 2 and what I will get is 16,380. Now again the number is divisible by 2. So I'll divide by 2 and I'll get 8190. Again the number is divisible by 2. So I will divide by 2 and I will get 4095. Now the number is not divisible by 2 as in the ones place there is no even number. So let us try with 3. Is it divisible by 3? So just check it. 9th hope you know that how to check the divisibility with 3. You find out the summation of the number. 9 plus 4 is 13. 13 plus 5 is 18. So 18 is divisible by 3. So you take the factor as 3, divide it and you will get 1365. Again you check the divisibility with 3. By adding the summation, so you will find out that it is divisible by 3. So you divide it and you will get 455. Again checking the divisibility with 2 and 3, if you will find out that it is not divisible by 3. So you will go to the next prime number which is 5. So you divide by 5 and you will get 91. Now 91 is neither divisible by 2, 3 or 5. So you will go to the next prime number, that is 7. So finally, you will get 13 which is the prime number. So you can write down that 32,760 is equal to 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. Correct or not? So this can be rewritten in the form of your exponent, that is 2 to the power 3 into 3 square into 5 into 7 into 13. So this is the way you can find out the factors of this number by using your prime factorization method. Now by using factorization tree, how you are going to obtain the factors? So let us start. So it is very simple. So what you are doing here, actually you are expressing this number as a product of a prime number and a composite number. Like for example 32760 can be written as 2 into 16380. Correct or not? Now 16380 can be written as 2 into 8190. Now 8190 can be written as 2 into 4095. Now 4095 can be written as 3 into 1365. Now 1365 can be written as 3 into 455. Now 455 can be written as 5 into 91, and 91 5 into 91. 91 can be written as 7 into 13. Correct or not? So you have got the last prime number which again cannot be divided into any number. Maximum what you can do? 13 into 1. So what is the prime factors of 32,760? So you can just write down here. So it is 32,760 is equal to 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. So now this number at this number, compare this value. They are same, right? So in both way you will get the same answer. So these are two methods in which you can find out the prime factor of your composite number. All these things you have already studied, so hope your knowledge has been refreshed today, correct or not? Okay, so all this what we are doing till now is nothing but the fundamental theorem of arithmetic. So let us know the statement of fundamental theorem of arithmetic. What is it? So the theorem states that every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occurs. Now let us understand this statement part by part. So first, every composite number can be expressed आज अ प्रोडक्ट ऑफ प्राइम्स. अभी हमने देखा पहले से पिछले दो स्लाइड में वही तो कर रहे थे. क्या कर रहे थे? कंपोजिट नंबर को प्राइम फैक्टर्स को लेके उसको हम एक्सप्रेस कर रहे थे. जैसे 6 हो गया, 2 इंटू 3 बना लिया, 10 हो गया तुम्हारा, 2 इंटू 5 बना लिया. तो इसमें क्या करते हैं हम? कंपोजिट नंबर को प्रोडक्ट ऑफ प्राइम नंबर्स के हिसाब से दिखाते हैं. नाउ कम टू द नेक्स्ट पार्ट, दैट इज एंड दिस फैक्टराइजेशन इज यूनिक. सो यूनिक मीन्स क्या? एक स्पेसिफाइड, एक स्पेसिफिक वे में एक्सप्रेस करना. ये जो प्राइम फैक्टराइजेशन है स्पेसिफिक तब बन जाता है व्हेन यू आर एक्सप्रेसिंग द प्रोडक्ट in a unique fashion, in a specific way. What is that specific way here? Here, while expressing it, so apart from the order in which the prime factor, so इधर प्राइम फैक्टर का ऑर्डर जो है उसको असेंडिंग ऑर्डर में हम अगर अरेंज कर देंगे, सो दैट बिकम्स unique. Like for example, just now we have shown, right? Like in case of your 32,760, that is, first we have written 3 2s, then we had written 3 3s, 2 3s, then we had written 5 and 7. So अभी देखो ये जो 2 3 5 7 असेंडिंग ऑर्डर में है ना. सो ये असेंडिंग ऑर्डर में जब प्राइम फैक्टरेशन को हम लिख लेते हैं, दैट बिकम्स द यूनिक रिप्रेजेंटेशन, एंड दिस इज नथिंग बट योर फंडामेंटल थ्योरम ऑफ arithmetic. So this fact is also stated in the following form: the prime factorization of a natural number is unique except for the order of its factors. In general, given a composite number x, we factorize it as x is equal to p1, p2, p3 up to pn, where p1, p2, p3 up to pn are primes and written in the ascending order. इसका मतलब क्या? p2 is greater than p1, p3 is greater than equal to p2 and so on and so forth till your pn. सो बच्चों, अभी फंडामेंटल थ्योरम ऑफ अरिथमेटिक का स्टेटमेंट समझ में आया? चलो अभी क्या करेंगे? तो अभी इसके रिलेटेड एक्सरसाइज 1.1, there is in question number 1 we have to find out the prime factors of the number. So what we will do is, I am not going to solve all the 5 problems. So what I will do, I will solve 3 problems here, that is bit 1, bit 3 and bit 5. This bit 2 and bit 4 I will give you as homework. Is that fine with you? Okay, so let us start. So I am taking the bit 1, that is I have to find out the prime factor. So 140 divided by 2, you get 70. Again it is divisible by 2, you take 2, that becomes 35. It is divisible, is this divisible by 3? No, it is not. So you take the next prime number and you get 7. So 140 is equal to 2 into 2 into 5 into 7. So that is 2 square into 5 into 7. Correct or not? So now let us go to the third bit. So because this 2 I will give you as homework. I have already told you this one and this one is your homework. So let us go to third bit, that is 3825. So we have to find out the factors of the number 3825. 5. So 3825. So it is not divisible by 2. It is divisible by 3. You divide by 3. You will get 1275. Again you divide it by 3. You will get 425. Again you divide by 5. You will get 85. Again you divide by 5. You will get 17. So what will be the factors? So these are the factors. So 3825 can be written as the product of these prime numbers, that is 3 into 3 into 5 into 5 into 17, that is 3 square into 5 square into 17. Correct. So now let us go to the fifth bit. Let us see the question 7429. So we have to find out the fifth bit, that is 7429. We have to find out the factors of 7429. So 7429, so you check with 2, you check with 3, you check with 5. So in ascending order you keep on checking the which prime number is divisible by 7429 by trial and error method, and you will obtain that finally it will be divisible by 17. So you divide by 17, you will get 437. Again you check with divisibility in ascending order and you will obtain that 19 is the number which is divisible by 437, and you get a prime number here. So the answer for 7429 is nothing but it's a product of 17, 19 and 23. Correct, children? So with this question number 1, I have solved 3 problems, and for you the homework is question number, so let me write the exercise so that you won't be confused. So exercise 1.2, question number 1, bit 2 and bit 4 is the homework for you. So you please solve it and put the answer in the comment section. Okay, children? So with this, I will end up today's class. Thank you so much for your patient hearing, and don't forget to enroll yourself. Please like the video, subscribe the channel and share. Follow us in YouTube, Instagram, Facebook and Twitter. Okay, and share with your friends to avail the same facility. Thank you, children, once again. Bye. Take care.